as far as we can tell.
Yeah.
The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for joining us today on Industrial IoT Solutions. I'm here with Bruce Collins, and just as always, if you have any questions throughout the presentation, feel free to ask them on the text box on the right. And we're going to have to end a little bit early today. We have to be off by 9:50, so just to give you a heads up there. Without further ado, here's Bruce.
All right, thanks, Colin. And as Colin mentioned, we're going to talk today about our industrial IoT solutions. I'll give you some updates on a few more of the features of the product, a little more of a deep dive on our particular cnReach product. But I'm going to spend the first probably 25 or 30 minutes going through a presentation, and then we'll have time for questions, and then we'll wrap. So. The background in this topic is we're really, Cambium Networks is already a player and a provider of industrial Internet of Things solutions, and that is that's everything from our remote office Wi-Fi hotspots, our video surveillance solutions using our 450i, lease line replacement with our PTP 650, and then in general. The PTP 820 for some of our long-haul backhaul or licensed backhaul. When we look at that portfolio, we said, well, what's the other piece that's missing? And so what we've introduced recently is the cnReach product, which is used for SCADA process control and sensing. And what ties all of these sort of applications together is that they all require a wide geographic area. They all require multiple points of presence, so lots of different locations that I want to connect back to a specific area. And then the need or the to move data, we call it here confidently and confidentially, so really both securely and reliably across the network. And really when you look at Cambium Networks, think of us as the transport company that can move data from point A to point B. So we're not developing or sensors. We're not doing the analytics, but we're connecting all that raw data across these wide areas back to where analytics can be done. And the utilities or areas that this is most useful in, the critical infrastructure, which is electric utilities, and that can be both investor-owned utilities or municipalities, oil and gas, rail, water treatment and wastewater treatment, storm management, and then also intelligent transportation as we get into the smart cities and being able to monitor traffic situations. So that's kind of the verticals that we look at. I'll give you an example here. This is an electric utility schematic that shows the use of Cambium products. Starting in the left there, you see a licensed microwave ring, and then you'll also see the spurs coming off of that. So that licensed microwave ring might be a PTP 820. Then you'll see spurs coming off of that, which could be, again, an 820. It could be a PTP 650, or it could be a point-to-point 450i, for example. Then you'll also see some point-to-multipoint topologies. And what's new here is you'll see a couple things. One is you'll see the little Wi-Fi symbol. That's where our CN Pilot product could fit in to provide local access for fieldcraft and contractors that might be locally on the scene that want to be able to get access back to the headquarters. And then you'll also see some areas where we're connecting to RTUs or PLCs at the substation, and that's where the SCADA process control and monitoring comes in. And I won't spend a lot of time on these, but that same architecture really fits and applies to the oil and gas space. And you can kind of recognize the similar topologies here, both point-to-point, point-to-multipoint. And then also on water and wastewater treatment. So this is, again, very similar infrastructure, very similar topologies, but the products themselves are the same but being used across multiple verticals. And this is kind of a tabular view of those products lined up in the different sleeves that really apply to the industrial IoT. So one of the objectives that we have at Cambium is to consistently keep a set of features on each of these product sleeves that are best or well suited to industrial applications. So whether you're talking about the 820 or using 450i for video surveillance, or now with cnReach being used for narrowband control and monitoring, we want to apply the same levels of security, reliability, and performance and scalability across all of these. And the other thing that ties all these together is the use of cnMaestro, which is our cloud-based or premises-based network management system, and then Link Planner, which is the tool that can be downloaded from our website at cambiumnetworks.com and used for management and planning. So so with that, I'm going to move into the narrowband product and give you a brief overview of that product, how it's used, how customers are deploying this, and give you some sense of the differentiation and benefits of this product. So there's an example of how you might deploy a narrowband solution, and this is a very typical example. What you'll see in the upper right there is a wellhead, a pump jack. This is a place where I would want to monitor things like pressure, plunger position, turn valves on and off. One of the key applications here is if I can monitor the current load on that pump and monitor the plunger position, I can start to do predictive or proactive maintenance on that site. So if I see current draws going up every time the plunger is moved, I might see that there's something that needs to be done before that is taken out of operation. Tank batteries, I'm going to monitor levels of water and oil and whether hatches are open or closed. Certainly I can monitor temperature and pressure at other points in the process, where you see with the flare and the separator. And then as you go to the upper left, you'll see point-to-point and point-to-multipoint application topologies, and that really gives you a sense of how do I take all of those sensors and meters that I want to pull information back over a large area. And with a narrowband solution, you can cover lots of distance in lots of different topologies, whether it's a relay, a point-to-point, or a point-to-multipoint. So, and there are definitely multiple ways of doing this. We look at three alternatives. One of them is a private network solution, and that's what Cambium Networks provides with our cnReach product. On the far right of this table, you'll see carrier networks, and that's where I might use the existing 3G or 4G carrier network to attach. And then there are some newer evolving standards based on LoRa or low power wide area networks that can be used for connecting primarily for reading meters, but it's another alternative. Now, when you look at private networks, there's benefits that the products are available in licensed or unlicensed spectrum. You can really tailor the coverage of a private network to exactly what you're trying to achieve, whereas a 3G, 4G network is going to more typically be deployed where people are rather than where these industrial machines are. Again, availability, the reliability and control that you have over your own private network versus relying on a third-party network gives you a better sense of designing in the right level of availability, and that's where Link Planner can help as well. Probably the biggest difference is funding. With a private network, you're buying the product, you're going to capitalize it over maybe a 7-year, for example, life cycle, and then alternatively, you're going to be paying an OPEX expense every single month to a third party to manage the network. So you can kind of make that trade-off between capital expense and operational expense. And then again, capacity and security are both areas where with a private network solution, I can exclusively dedicate capacity to a particular application, and I can secure it to my own IT and information assurance requirements rather than relying on a third party, again, that might not have the same level of detail and responsiveness to new requirements. So when we look at cnReach, there's a number of attributes that were really important in coming out with a SCADA process control and monitoring solution. We looked at deployment flexibility. Can I deploy this in a point-to-point, point-to-multi-point mode, as well as relay modes? I'll talk about those in a bit. Having some built-in I/O. We have some customers that would like to connect to maybe a cabinet door or something local to the cabinet that the radio is in, without having to add additional I/O onto the PLC. So this makes it quite simple to do the connections to some local sensors. For reliability, we test every radio 100% over temperature. The products are ATEX HAZLOC Class 1 Div 2 compliant, which means I can operate these in an intrinsically safe mode in an oil and gas environment. And the product is manufactured here in the U.S. Another area that's important, especially in some of the oil and gas and water treatment areas, is to keep the power low. And that's really a few watts or less, depending on how active you're pulling. And a lot of times these are sites that only have solar power, or they want to, or it's being deployed with a battery backup solution. So I need to make sure that I have enough battery capacity. So again, keeping the power low is important. Even if I do have AC mains power, typically for battery powered operation, you want to keep this power low. Scalability is important. And we do scalability in a couple ways on this platform. We do access point synchronization, which is similar to how our other PMP products are synchronized, where we're trying to make sure that if I have multiple access points on a tower, that they're always transmitting and always receiving at exactly the same time without talking over each other. So that's a way, and the product supports basically interconnecting multiple access points to do self-generated sync, or I can use the Cambium Networks UGPS to provide a GPS-sourced 1 pulse per second reference signal to feed multiple towers. So even if I have towers that are within a few miles of each other, I can make sure that those are all synchronized. And then we also support what's called adaptive modulation. And adaptive modulation means that the radios will adjust their speed and capacity based on the current signal conditions or environmental conditions, which means that radios closer into the tower might operate at a higher speed, and radios that far away from the tower might operate at a lower speed. And they'll always optimize to the best speed that they can achieve given the noise floor and the distance and propagation of the signal. That's useful in a number of ways, but primarily that means that I can more efficiently run the network and be more spectrally efficient, because those radios that are near in can run at a higher speed, and they can get on and off the network more quickly. So those polling cycles can be done much more quickly, and at the same time I can still cover a large area. Then we talk about security. We have 128 256-bit AES encryption built in. We also have a number of features like a read-only web GUI that you can make sure that if you're going to give to a technician that is not meant to be configuring the radio, but they just want to see what's happening in the radio, they can do a read-only mode. We also have login banners to make sure that you don't, if you do have somebody attacking like a cyber attack, you can make sure that if they connect into that management interface, that you're posing a question to them to say that do they know that they're coming into a system that they're not allowed to, which makes it easier to prosecute in the future. And the last item on here is manageability, and that I'll talk a bit more about that, but effectively the product is supported today in a point-to-point mode with Link Planner, and then in the future we'll be adding CN Maestro support, and that's expected to be in a beta scenario in January. So work is progressing quickly on that, and we expect to have that available for a beta in January. And that'll be both on the a premises-based version, or you can deploy this in the cloud so that you you don't have any local system to maintain or manage. We have a lot of our customers have the experience with broadband, And what we're showing is a narrowband product here. So one of the questions we get quite a lot is, well, why would I choose a narrowband product that's operating in 50 kilobits per second or a few hundred kilobits per second when I have these other products that are operating in megabits or gigabits per second? And really some of the benefits of narrowband it's really around the physics. I can go with the lower frequency. I can cover the propagation is better. And I can get through some foliage by using a sub 1 gigahertz frequency. Also by using really narrow channels, I can result in a higher link budget. So we talk about, in this case, for example, a cnReach radio might have a modulation that goes to, say, a negative 110 dB in the receive sensitivity, where a typical broadband radio in the same frequency or the same channel might be at neg 89 or 90. So almost a 20 dB better link budget, which lends to both higher system availability and also extended range. And then lastly, the licensed narrowband operation typically allows for higher power than a traditional unlicensed spectrum. So there's some benefits for these applications. And then even within the narrowband, there's options for unlicensed or licensed. In unlicensed, today this is unlicensed 900 megahertz. In this case, it's using frequency hopping, which means that I'm going to take that entire spectrum, in this case 902 megahertz to 928 megahertz, and I'm going to slice it up into a bunch of individual small channels. And the radios are going to only sit on a particular channel for a very short period of time, like perhaps 60 milliseconds as an example. And then it'll move on to another channel. And that'll reduce statistically the opportunity for interference, and as it moves from channel to channel. A license is going to be tailored specifically to the channel that is fixed by the license. That's either here in the U.S. from the FCC or whoever the local regulatory body is in the individual country. I think the other items on here are really showing some of the similarities with an access point to remote module. With license frequencies, typically those are deployed in licensed pairs. This radio can operate either on a single half of that pair, so you can transmit and receive on the same channel, or you can split that across the frequency pairs depending on how the channel is allocated. At the end of the day, though, these are both TDD radios, so that last line item there, which is, are the access points and endpoints transmitting at the same time? No, it's done through a mechanism which I'll show you here in a second. Here's an example of the hopping pattern. I can set up different hopping, and what you see in the channel as an example, here are 16 different channels. And these are all sub-channels within that 900 megahertz spectrum. And what the radio is doing is, if I set it to pseudo-random, it's going to sort of hop around to different channels, never dwelling on one channel for more than, say, 60 milliseconds. And in that pseudo-random fashion, it will minimize the times that it collides with another radio in the same geographic space. I can also establish a particular hop pattern. You can see that hop pattern below, where I'm going to go from, say, 1 to 6 to 12 to 18, and then cycle back around. And that more prescribed hop pattern is useful if I'm going to synchronize my access point with another access point. I can have them all be on a pattern of skipping every 4 channels, and then have the next radio next to it start on channel 2 and skip every 4 channels. And now I have both of those APs operating next to each other. They're synchronized in a TDD fashion from the 1 pulse per second signal, and they're also then synchronized in their hop pattern, so they're never on the same exact channel. We also get some questions about the air interface. This is a TDD solution, so it's going to spend part of its time transmitting on that channel and part of its time receiving. If it's a point-to-multipoint application, it's going to have a beacon that sends out so that new remote or endpoints can join the network based on identifying that beacon. And then the way it works is there's a scheduler that schedules transmissions to endpoints, either unicast or broadcast, and that's all based on a queue. The uplink requests are made in that short duration in the middle, which is where an endpoint can say, I need more capacity, I have some more data I need to send, and that will get fed back into the scheduler. The Mac also supports a retransmit capability so that it can be set up that it continues to try the same packet to the same endpoint up to say for example 3 times, and if it doesn't receive an acknowledgement, it'll retransmit. So it gives you the opportunity to have a little more reliability in the network. And then that frame duration it's not a fixed frame. It's going to depend on how you configure your payload bytes and how you configure the maximum modulation mode. And that's described in the user guide, how you can configure all that. So it's quite flexible on how you manage that. So let's talk about the particular products. The 900 megahertz product is the first version here, and that's available in both licensed and an unlicensed spectrum. You'll see in the frequency, and so by the nature of the spectrum, it's typically available in the US, Mexico, Canada, Australia, and then there are some other places in Eastern Europe and Africa that have access to 900. You can see it can operate in either licensed or unlicensed, so the same radio through a software configuration can be swung from licensed to unlicensed, and then that will dictate which channel sizes are available and what can be used. And here's another example. You see the difference. In a licensed channel, I can go up to, we're actually increasing this up to about 4 watts, but I can only go up to a 50 kilohertz channel. And in the unlicensed spectrum, I'm limited by the FCC to the 36 dBm EARP, and but I can go to much wider channels. I can go to a 1.2 megahertz or 1200 kilohertz channel, which means the capacity can be significantly higher. These are over-the-air capacities, so your usable throughput will be a little bit less than that. But we typically have seen in deployments a maximum of about 1 meg in each direction on a unlicensed, and a couple hundred kilobits on the licensed band. We also have a 700 megahertz product. This is 700 megahertz is primarily, as far as I'm aware, only available in the US. There are 2 1 megahertz chunks of spectrum here, and these are licensed exclusively from a company. There's a couple of companies that currently own the spectrum. One is called Access Spectrum, and the other is called Select Spectrum. They own the nationwide license for this, and they are in the process of selling that to individual operators. And there's a lot of interest in the electric utility space to purchase some of the spectrum. In the end, this is a licensed band, and when you purchase the spectrum, you would own the entire 2 megahertz in the geographic area that you purchased the spectrum from. We did another webinar on that a couple weeks ago, and you can along with the folks from Access Spectrum and Select Spectrum, and that post is available on our community forum. So if you want to take a look at a little more of a deep dive on that spectrum itself, I'd recommend going and taking a look at that other webinar. In first quarter, after the first of the year here, we're going to be introducing 450 megahertz product. This will cover this bands you see here, 406 to 430 and 450 to 470. There are different power outputs, and we're working through the FCC certification on this one, but we believe it'll come in around 8 to 10 watts. And then the ETSI is going to be a little bit lower, quite a bit lower, but at 2 watts to fit within the ETSI requirements. While the radio itself can go up to 250 kilohertz, most of the times licenses are generated for the spectrum are typically 12.5 kilohertz. So this is typically done using a very narrow channel and using a low capacity of, say, 10 to 20 kilobits per second. So it's a low throughput, but the spectrum in many cases is pretty widely available, especially if you get outside of urban areas. So look for more information on that to come in first quarter. So the other thing I want to point out was the topologies. This product can be deployed in a variety of modes, and in all these cases it's the same basic radio, so it's the same platform from a management perspective, a user interface perspective, connectivity, installation practices. But there are a couple of things I'll point out here. One is it can be clearly deployed as a point-to-point mode in the upper left. And then as I get into more complex scenarios, I can do point-to-multipoint. And off of the kind of in the center of the screen, you'll see what's called store and forward repeater. And that's where I take a single radio, and I'm going to have an omni antenna on that, and I'll be a relay node within a network or a repeater node in a network, talking sometimes to the access point and sometimes to the endpoint. Now, clearly, what happens there is you lose speed and you increase the latency because that radio is spending part of its time talking, say, west and part of the time talking east. If you drop down a little bit on the slide, you'll see what's called a back-to-back repeater, and that's where I can take a cnReach module that has two radios in it. So we have a dual radio option. Now I can fit that with two Yagis, one pointing in the west direction and one pointing in the east direction. And that, in that case, the back-to-back repeater is not losing capacity at that node, and it's also not losing latency in that node because I can basically regenerate that packet at that interim relay point. And then, of course, that could also be in the eastbound direction there. That could also be a sector antenna and could feed multiple endpoints. So I could actually have a back-to-back repeater that has a Yagi going back to the tower and then a multi-point sector going to individual endpoints further downstream. The connectivity on these radios, let's see if I have a, yeah, let me jump back here. Let me jump ahead to this other slide here. This is kind of showing the connectivity and the interfaces on the radio. I'm going to give it a more up-close view. You'll see on the front there, there's two serial ports and two Ethernet ports, and then a DC power connector. The DC power can be anywhere from 10 to 32 volts DC. Very typical deployments for our customers is to use a 24-volt DC rail, and then these are typically mounted inside a cabinet alongside that 24-volt supply. That gives you kind of the best trade-off in efficiency and current load and everything on the radio. So while it'll run from 10 to 32, 24 is kind of the sweet spot. You can also see there on the top right picture, there's a green bar or green connector. That's where the optional analog digital I/O can be fed, and that can be set up to do either input or output, and it can read frequencies for counting type applications, or it can drive a relay closure, for example, if you want to set a switch, or in an input mode you can read a switch. That's an optional feature. One thing that's always there is the first couple of pins, which that's where I can connect a UGPS to provide my 1 pulse per second reference signal in a synchronized scenario. And then in the lower right, you'll see a couple of TNC RF connectors, and that's where the antenna is connected. This is a single polarity radio. What's shown here is our dual radio module. So if you buy a single radio module, there would just be one of these connectors, and the dual radio has the two. We also offer this product without any radios, and that's what we call our I/O expander. And that product, because it still has all the rest of the I/O, the serial ports and the Ethernet ports, is useful to put on the end of a broadband network. So let's say I have a MP450i network that I need some serial connectivity. Using a cnReach I/O expander is a good way to interconnect with that serial data. So essentially with that connectivity, I can connect anything that has a serial port on it. I can connect to, and you can see the RS-232 traditional. I can also do a serial bus like a 422 or 485. It carries transparently, it carries the DNP Modbus protocols and can be configured for that. Those I/O pins and signals can be read with a typical Modbus register, so they can be addressable via Modbus masters. And then with the Ethernet ports, I can connect pretty much anything that would look like a terminal server client interface, or I can, with say a command line interface, or it can be anything that has a more traditional Ethernet with a port connection. The other thing that's important to note is that this product can be deployed just as a complete flat layer 2 network. There's VLAN tagging support in that case. but it can be done very simply with layer 2. If you'd like to, you can deploy this with static layer 3 routing, and that's useful for scenarios where I want to prevent packets from going out over that radio interface because of it's a narrow band and I don't want broadcast traffic going out over the air. So I can set up some layer 3 routing to make sure that I'm only routing broadcast traffic in a particular location or particular direction. I can also route certain types of traffic over the, let's say I have a dual radio module and I want some critical information to go out over the licensed channel. I can route that over the licensed channel radio. And then the unlicensed radio, I can maybe do my meter reading or less mission critical sensor data that can come across that network. So I can kind of tailor that. Well, in first quarter, we'll also be adding some IP filtering to be able to do some of this at layer 2, where I can basically block traffic from individual IP addresses even in a layer 2 network. The radio can be configured with a web-based management interface, so you can log in using HTTPS. You connect, you can do distributed firmware updates. We have some features in here that allow you to distribute software updates using a small amount of the available payload data, so I don't overload the payload traffic, but I trickle that software update out over a period of time. And say maybe I want it to go out over a 18 or 24-hour period, so that I don't interfere with the payload traffic, but it continues to push through. As I mentioned before, we'll also be adding cnReach to the cnMaestro network management system. This is Cambium's product for either cloud-based or premises-based management. And I believe I have a little screenshot in here of this. A couple of things that you get with cnMaestro is a nice geographical view. You can locate where all these radios are on the on a map, and that GPS coordinates can, with the software release we have coming out right here at the end of the year, you'll be able to enter the lat-long coordinates of each device on the GUI itself, or you can have that sort of entered up on Maestro to keep track of dragging and dropping where these items are located. You can also see in the kind of the middle column there's a hierarchical display. I can see everything's green there, and I can kind of walk down the tree and say, here's an access point with 2 endpoints. Similarly, on the left, I can see that hierarchical view, and I can understand if I'm feeding a large number of cnReach radios, and maybe my SCADA automation team is reporting that I can't reach, we're not getting data from a certain wellhead, for example. I can go onto the system and it'll tell me that it's either a widespread outage due to, say, a backhaul link is down, or is it tailored particular to that scenario. So you can very quickly get to the bottom of a troubleshooting scenario. And I can also monitor performance history on the screen below, and you can see how much traffic and what's the typical polling cycles and that sort of thing, and what's the modulation and RSSI level on that radio. So I can see where I'm deploying these through foliage, I might see some degradation on connectivity to a certain node as the trees grow up around that device. And I can monitor this and see if I have devices that are starting to be impinged upon from external sources, and I can see if that signal level is decaying over time. Link Planner, if you download Link Planner today, you'll see the ability to plan a 900 megahertz unlicensed or licensed spectrum with cnReach. It'll give you the over-the-air capacity. It'll tell you what kind of terrain is between point A and point B. And the nice thing about this product is Link Planner is that it is suitable across all of our different products. So I can do point-to-point, point-to-multi planning all within a single tool in a single project file, and then have it generate a proposal report or have it generate a installation report so that installer knows what they should expect to see when they arrive on scene to do the install. There are a couple questions that came in. I want to hit those now, and if you have other questions, feel free to put them in the chat window. There's a question on, let's see, the first question here is this open source that I could program it? No, this is This is a not an open source product. It is a completely sort of developed product. Certainly, if you have feature requests, you feed them back through us, and you can post those on the forum, and we could look at how to add those features. I'd be curious kind of what you have in mind there. Next one is what's the number of devices I can have in a multi-point network. So in a point-to-multi-point scenario, let me go back to this. In a point-to-multi-point scenario, there's not the theoretical limit is quite high. A more practical limit is probably say 50 to 75 off of a single access point. It's going to depend on your polling cycle and how much data you're trying to pull. And then at some point it becomes more efficient to split that into multiple sectors. And I can do that in a couple ways. I can have multiple layers of multi-point. So as an example, in that store and forward repeater case, where it's an omni, I can actually have, I could fit a sector on there and then feed a number of devices in that sector. So what you would see in that case is a cascaded or tiered point-to-multi-point scenario where I have an AP feeding an endpoint, which is then respectively feeding multi-point below that. So you can get quite complex in the topologies and connecting up different places. And then the last question I see on the window here is the ability to project with an omni. You can certainly use an omni. That's a common scenario. It's also commonly used in a point-to-point environment with a Yagi antenna, a single pole Yagi. And then there's also, this is also deployed with sectors. So I could say put up a 90-degree sector and have that be providing just coverage for that area. So a lot of flexibility in both the topology and the types of antennas that you would use. Then there's a question about whether this product is suitable for IP cameras for video surveillance. It certainly could be used for that. That's not a typical situation. More likely you'd use one of our, for example, our PMP450i or PTP450i for video surveillance. If you have a sort of a low data rate camera, or you have a camera that you want to do sort of a frame every, basically a low refresh rate on that camera, you could do it that way. And then the other thing I've had customers do is, or describe, is set up a narrowband with the alerts or alarms. So if a sensor is tripped, then it could engage a video camera through some other parallel connection. So there are some ways to interconnect this with video surveillance systems. And then there's another question here, which is how do I take if I have an existing network that's doing SCADA, can I bring a cnReach into that same environment? And the short answer is yes, that's done all the time. And there's multiple ways of doing it. You can, in an unlicensed spectrum, for example, you can set up different portions of the 900 megahertz spectrum for the legacy system and certain portions for the new cnReach system. In licensed channels, I can operate these alongside an existing network. And then there's also ways, based on the synchronization techniques that we use, to minimize the interference that would be caused or come from the other sources. So I'd like to hear more about that. If you have an idea on how, or if you have a installed base that you'd like us to take a look at, we could certainly go through that and make a recommendation on how to do that migration. One of the things I would point out is that Cambium support on cnReach, we have a large group of channel partners and a lot of distributors in North America and then also around the world. So you can work with one of our channel partners and they can help you with generating proposals and generating what it will take to deploy cnReach. We have a global sales team, so we have sales managers that are specifically focused on industrial communications. they can certainly help with that. And then we have what we call regional technical managers, and this is what sometimes is called as a sales engineer in other companies. We call them regional technical managers, but they have in-depth knowledge of the products. They can help you as you're making a decision on how you want to deploy the product. They can give you guidance on best practices from around the world. I should also point out that we have our community forum that's available at community.cambiumnetworks.com, and also you can link to it from our main webpage. We just passed over 10,000 users on that community forum, and so there's a lot of different ways to get information from your peers out there that are deploying the same product. Our engineers, our product line managers, our support team is active on that community forum, and often that's a way to find even the most obscure question can get answered on that. And then, of course, we also have our traditional call center support, which can be escalated up to our Tier 3 engineering support that sits alongside our engineering and product management team here in Chicago. That, again, is a way to make sure you're happy with the deployment and make sure that the system is behaving as expected. We have these webinars that are held just about every week. We have webinars on different topics. Those are all archived and posted on our community forum. So if you ever miss one or you want to go back and see something, you can go to the community forum and listen to that webinar again. We also are offering certified training. We'll be starting to do training on cnReach in, I believe the first class will be in early February. So that'll be something that you can come take a 2-day course and learn in-depth, hands-on how to set up a cnReach network. We also, of course, offer that training on all of our different products. And then the last thing is warranty. The radio has a 1-year warranty and can be extended up to a total of 5 years. So there's lots of options there as well. Let's see if another question came in here. Looks like we got just about all of them. I'm just trying to understand this last question on here. Yeah, it looks like the question is really around alarm systems and being able to transmit securely. So yeah, I think what the question is getting at is can this be used for security systems monitoring, and certainly that would be a good application for this. It uses encryption. It's a very reliable system, and you could monitor security systems with that. And then if you wanted to overlay that with our broadband products to do video surveillance, that would be a nice tiered approach or layered approach. So with that, I will bring this to a close unless there's any last final questions. But I do appreciate all your time. We recorded this webinar, so if you want to come back and revisit any parts of it, that information will be up on the site at community.cambiumnetworks.com. So thanks, everybody.
Yep. Thanks again.